Hello everyone, this is Pure Mathematics chapter 2. In this video we are going to discuss about section 2.1 exponential functions. So let us look at the definition. For any positive number a not equal to 1, a function of the form y is equal to a power x is called an exponential function. So this is the definition, from which what we understand is any function of this form y equal to a power x, and this a is called the base and x is the exponent or the power. So any function of this form is a exponential function where this base a is positive number and a is not equal to 1. So we write y equal to a power x where a is greater than 0, that is positive, and a is not equal to 1. So the base must be positive number and not equal to 1 means either the base a is between 0 and 1 or the base is greater than 1. Then this form, any function of this form y equal to a power x is called an exponential function. So here we can say a lying between 0 and 1 or a is greater than 1. Let us look at some examples. Y is equal to 3 power x. So this is of the form y equal to a power x where a is equal to 3. The base is 3 here. And since 3 is greater than 1, it is positive and it is greater than 1. So it is an exponential function. Next example, y is equal to 1 by 5 power x. Again, if we compare with this y equal to a power x, a is equal to 1 by 5. So this 1 by 5 is greater than 0, positive, and 1 by 5 is less than 1. Therefore, it is an exponential function. So this base can be any number which is positive, that is greater than 1, and it can be either less than 1 or it can be greater than 1. Positive, and it should not be 1. So either less than 1 or greater than 1. So in the first case, it is a positive number, the base a is 3, which is greater than 1. So it is an exponential function. In the second example, the base is positive, 1 by 5 is positive number and 1 by 5 is less than 1. So it is an exponential function. Let us take the third example, y is equal to minus 2 whole power x. Here the base a is minus 2. Minus 2 is less than 0, it is a negative number. Therefore, this is not an exponential function. For an exponential function, always the base should be positive and base should not be equal to 1. Not equal to 1, and it should be positive. Let us look at some properties of this exponential function. The domain of the exponential function is R. R is the set of all real numbers. So domain means the x values. When the exponential function is given, y is equal to a power x, what are the x values we can take? X can be any real number, either positive real number or negative real number or 0. That is the domain. And the range of this exponential function is R plus. R plus is set of all positive real numbers. That means the images or the y values are always positive real numbers. So here, if you look at that graph, the y values you will get only positive values. You don't get y negative. Y is always positive. That is the range. So the range of exponential function is R plus. And if the base a is greater than 1, then this exponential function is an increasing function, like here. It is increasing function if the base a is greater than 1. And if the base a is between 0 and 1, that is base is less than 1 and it is positive, then the exponential function is a decreasing function. Here you can see the exponential function will be decreasing like this when the base a is less than 1 and a is positive. So a is positive is already there, required condition for exponential function. and if the base is less than 1, it will be a decreasing function, and if the base is greater than 1, it will be an increasing function. And the graph of this exponential function is always continuous. That means there are no breaks. It is a continuous function. So there are only two types, either it is increasing function or decreasing function. That depends on the base. If the base is greater than 1, increasing. If the base is less than 1, it is decreasing. But the base always should be positive, and base should not be equal to 1. That is from the definition. Let us look at some examples. Find the domain range of the exponential function y equal to 0.1 power x and verify the graph is increasing or decreasing. So the given equation y equal to 0.1 power x, this is of the form y equal to a power x, where a is equal to 0.1. So 0.1 is positive number and it is less than 1. So when the base is positive number and the base is not equal to 1, some number not equal to 1, y equal to a power x is always exponential. Here y equal 0.1 power x is exponential function where the base is positive, a is greater than 0. And if you put x is equal to 0 in this, you will be getting y equal to 0.1 power 0, that is equal to 1. So for x is equal to 0, y equal to 1. Therefore, this exponential function passes through the point 0, 1. And the domain of this exponential function is always R. That means x values, you can take any values of real value, positive real number or negative real number or 0. And the range is R plus. For any exponential function, the range is always exponential function R plus, the positive real numbers. So y values, the range means the images are the y values are always positive. And here the base a is less than 1. Therefore, the graph will be a decreasing function. The graph is decreasing because the base is 0.1, which is less than 1. Let us go to another example. Find the domain range of exponential function y is equal to 5 power x and verify the graph is increasing or decreasing. So if we compare this y equal to 5 power x function with y is equal to a power x, then a equal to 5, the base will be equal to 5. And this base is positive, 5 is greater than 0. And 5 is not equal to 1, it is greater than 1. Therefore, this is an exponential function and it passes through the point 0, 1. If we put x is 0 here, y is 5 power 0, that is equal to 1. And the domain of the exponential function is always R. And the range of the exponential function is always R plus. The y values are always positive, the images. Y is nothing but the range. Range is always positive real numbers. And here the base a is greater than 1. Therefore, the graph of this exponential function is increasing because the base is greater than 1. Now let us go to some equations solving exponential functions. And before that, we look at some properties of exponents. The first property, a power m times a power n is equal to a power m plus n. That means when we are multiplying two exponents, if the bases are same, then we add the powers. So this a is called the base and m is called the exponent or the power. So when we are multiplying two exponents with the same base, then we add the powers. So a power m times a power n is a power m plus n. The next, a power m divided by a power n is equal to a power m minus n. So when we are dividing two exponents, we subtract the power of the denominator from the power of the numerator. So the numerator power is m, the denominator power is n, and the bases are same, a. Therefore, a power m divided by a power n is equal to a power m minus n. In third property, a power m whole power n is equal to a power mn. That is, when there are two powers in the exponent, we multiply both the powers. A power m whole power n is equal to a power mn. Fourth property, a power 0 is equal to 1. For any real number, if the power is 0, the value is 1, provided this base is not equal to 0, because 0 power 0 is not defined. So a power 0 is always 1 for any real number except 0. And fifth property, ab power m is equal to a power m b power m. So if there is a one power and two bases, and this power is applicable for both a and b, a power m times b power m. Sixth property, a by b power m is equal to a power m by b power m. So if there is a fraction and there is a power in the exponent there, m is the power, then this power is applied to both the numerator and the denominator. So a by b power m is equal to a power m divided by b power m. And seventh property, 1 by a power n is equal to a power minus n. So if we have 1 in the numerator and a power n in the denominator, we can write it as a power minus n. And eighth property, the radical expressions, square root a is equal to a power 1 by 2. Whenever there is square root, it is nothing but power is 1 by 2. And the nth root of a is equal to a power 1 by n. And look at the examples here. So the example for the first property is 2 power 3 times 2 power 5. So we are multiplying two exponents with the common base. Base is same. Then we add the powers. That is the first property here. So 2 power 3 times 2 power 5 is equal to 2 power 3 plus 5. That is equal to 2 power 8. 3 plus 5 is 8. And next one, 2 power 4 divided by 2 power 2. We are dividing two exponents with the same base. Then we subtract the powers. So 2 power 4 by 2 power 2 is equal to 2 power 4 minus 2. That is equal to 2 power 2. And the example for the third property, 4 power 2 whole power 3. There are two powers like here. Then we multiply both the powers. Therefore, 4 power 2 whole power 3 is equal to 4 power 2 times 3. That is equal to 4 power 6. 2 3s are 6. And fourth property, 5 power 0 is equal to 1. Any value a power 0 is always equal to 1, where a is not equal to 0. And fifth property is example 2 times 5 power 3. So when there are two numbers in the base product and a single power, this power is applicable for both the numbers. So 2 times 5 power 3 is equal to 2 power 3 times 5 power 3. An example for sixth property, 2 by 5 power 3 is equal to 2 power 3 divided by 5 power 3. An example for seventh property, 1 by 3 power 2, you can write it as is equal to 3 power minus 2. Both are equal. And eighth property example, root 5. Root 5 is nothing but 5 power 1 by 2. Whenever there is square root, it is nothing but power is 1 by 2. And fourth root of 2 is equal to 2 power 1 by 4. So in general, we write nth root of a is a power 1 by n. So here fourth root of 2 is 2 power 1 by 4. So this is the example for the eighth property. So using these properties of the exponents, we try to solve some equations now. Let us take this example. Solve 2 power x minus 3 is equal to 32. So this is an equation having exponents. Solving means finding the x value. So to find x value, we try to write both sides of the equation as a power of a prime number. Here 2 is always a prime number, and 2 power x minus 3 we leave it as it is because it is a power of a prime number. On the right hand side we have 32. So we try to write 32 as a power of 2. So 32 you can write it as 2 power 5. 2 power 5 is nothing but 32. Therefore this equation can be written as 2 power x minus 3 is equal to 2 power 5. In place of 32 we can replace it by 2 power 5. So that the equation has exponents of the same base. 2 here, the base, here also the base is 2. So equation having same exponent equation having same base here, base is 2, and therefore you can equate the exponents. Since the bases are same, we can equate the exponents. So x minus 3 is equal to 5. From that you will get x is equal to 5 plus 3, which is equal to 8. So whenever we have an equation having exponents, we try to write both sides of the equation as a power of a prime number. Here 2 is always a prime number, so we leave this left hand side as it is, and we try to write this 32 as a power of 2. Here 32 is 2 power 5, so we substituted 2 power 5 in place of 32. Then both sides of the equation have the same base 2, so we equated the exponents or the powers and we got the value of x. Similarly, we have the second example. Solve 27 power x plus 1 is equal to 9 power 2x. Here we try to write 27 as a power of a prime number and 9 also as a power of prime number. Then we equate both. If you observe, 27 is equal to 3 power 3 and 9 is also can be written as a power of 3. 9 is equal to 3 power 2. So if we replace 27 by 3 power 3 and 9 by 3 power 2 in this given equation, we will get 3 power 3 power x plus 1 is equal to 3 power 2 power 2x. So there are two powers here. So from the properties of the exponents, you can multiply both the powers. So the equation will be 3 power 3 times x plus 1 is equal to 3 power. Here also multiply both the powers, 2 times 2x 4x. So we obtain an equation where both bases are the same. Here 3, here also 3. Therefore we can equate the exponents or the powers. We can equate the powers. So 3 times x plus 1 is equal to 4x, which implies if we expand 3x plus 3 is equal to 4x. From that you will get x will be equal to 3. So this is the solution of this equation. So here we have some example problems here for exercise. You can solve these problems. If we take the first problem, 5 power x plus 1 is equal to 625. The left hand side of the equation is a power of a prime number 5. 5 is a prime number. So we cannot write this further as a power of a prime number. We can leave it as it is. The right hand side is 625. 625 you can write as a power of 5. Then equate both with the same base 5. If both right hand side and left hand side are powers of the same prime number 5, then you can equate the powers or the exponents to get x value. Similarly, you can try the other problems and you can write the graphs of these functions. So this is the end of this presentation.